Hi everyone, this is lesson 213 on Converses. This is a continuation from chapter 1's topic on conditional statements. And so what you should already know is what a conditional statement is. And if you don't remember, here's a reminder of that. And here's kind of a summary of really what we're covering in this lesson. All right, so a conditional statement is a statement that begins with an if, followed by a hypothesis, then a conclusion. For example, if it's raining outside, then the ground is wet. Right? That's a conditional statement. If this is happening, then this must also be happening. So if the sky is blue, then the ground's wet. Right? The statements don't have to be true, but the fact that it's in an if-then phrase makes it a conditional statement. When you reverse the order of the hypothesis and the conclusion, right? When you take the hypothesis and conclusion and you swap them, that gives you a converse of the statement. So any statement, every statement can have a converse. And all you have to do is begin, you're still going to begin with the if, but then you're going to follow it with the conclusion, then the hypothesis. And we'll go through a few examples in a minute, and this will make more sense when we go over examples. All right, so a couple more things you need to know is every conditional statement has a converse. A conditional statement can be true or false. All right, just because you have a conditional statement doesn't mean it has to be something that's true. For example, if I said, if tomorrow I wake up at 8 o'clock, then I will become a millionaire. All right, most likely that's going to be a false statement, but it's still a conditional statement. Its converse can be true or false as well. All right, so, and then we're going to do some examples. And then just as a reminder, I kind of showed you above. Another way of writing conditional statements is using arrow diagrams. So when we see this notation of an arrow, hypothesis, arrow, conclusion, this is the same thing as us saying if hypothesis, then conclusion. All right, so these two things are the same thing. Here, these are the same. So sometimes we'll see it in this form using the arrow diagrams. Sometimes we'll see it using the if and then. All right, so that's kind of the basics of what we need to know. We're going to practice a few examples and see if this makes a little bit more sense. All right, so the first statement we have, triangles congruent, and then we have the arrow, right, which is then. So this is like saying if the triangles are congruent, then all pairs of corresponding sides are congruent. All right, so that's our conditional statement. So is this statement true? You may or may not know the answer to this. We're barely learning a little bit about congruent triangles. But this is kind of a reminder that you do need to start to remember some of these facts about congruent triangles that we discussed with the congruency theorems. All right, so is this statement true? If two triangles are congruent means if these triangles are identical, then does that mean all the pairs of corresponding sides are congruent? Well, the answer to that is going to be yes. Is this true? Yes, this is true. All right, well, let's look at the converse of that. All right, so the converse, if you notice, if, and I started with all pairs of corresponding sides, all pairs of corresponding sides are congruent, then the triangles are congruent. The triangles are congruent, right? So all I did is I reversed the order. So this is the converse, right? Now we have the converse. Is this converse true? Well, if all corresponding sides are congruent, if I have two triangles and I have all the corresponding sides are congruent, then that's the same as side, side, side congruency, which means the triangles are congruent. So that's a true statement as well. Okay, so that's true. All right. And so that's kind of what we're going to be, that's what you need to be able to do, is take a statement, decide if it's true or false, right? True or false doesn't mean right or wrong. It just means, is it true or not, right? And then the converse as well. Can you switch the order, and can you decide if it's true or not? So here's another example, very similar. Triangles are congruent, then all pairs of corresponding angles are congruent. So is this statement true? Well, if the triangles are congruent, meaning all pairs of angles are the same and all sides are the same, then this must be true. All right, so that's also true. Well, what happens when we look at the converse? If all pairs of corresponding angles are congruent, again, you'll notice I started with the conclusion first, and then the triangles are congruent. That's the hypothesis. All right, so that's the converse. Is this converse true? Well, if all pairs of corresponding angles are congruent, all the angles are congruent. So the last I checked, there was no angle, angle, angle congruency. All right, that does not exist. All right, so that is not enough information to say that it's true. All right, so if it's not always true, right, it's possible that those triangles are true, but those triangles are the congruent. It is possible, but it's also possible that they're not. So if it's not always true, give a counterexample, right? So this is another vocab word that you need to know. So a counterexample is a statement showing at least one situation where a statement is false. So all you have to do is give me an example that proves that that statement is not true. All right, so that's, and it doesn't have to be a lot of examples, just one example. All right, so this would be one way of giving an example. If you can't say it in words, maybe visually. So here I have two equilateral triangles. All pairs of corresponding angles, all pairs of corresponding angles are congruent. So that means, I'm going to zoom into this. So this angle and this angle and this angle, they're all the same angle. But in this one, all these three are the same as well. Are these two triangles congruent? Right? All the angles are the same, and all the angles are the same here. Right? So this angle matches with this angle. All these angles are the same from both shapes. Are these two triangles congruent? Well, congruent means their sides have to be the same measurement. So if I look at the measurement of these, this has a measurement of 2, and this has a measurement of 3. These are not the same size. All right, so this is an example, or more so a counterexample, of why this is not a true statement. All right, so if you're going to put it in words, you could say two equilateral triangles They don't have to have the same side measurements. All right. All right, that's a little bit challenging. Again, if you're not familiar with triangles and the properties of triangles, then this might be a little bit challenging. We'll get to a couple that don't involve that. So here's, this is actually taken from some of the homework problems from the book. I think these are might be a little bit easier. All right, so I'm going to start this with you, and I actually won't finish it with you. I'm going to let you try to do these on your own. If you need help with it, you could always ask. Reach out to me if you need help with these. So write the converse for each conditional statement and tell me, is the converse true or not? And if you say it's not true, then try to give me a counterexample. All right, so I've done the first one for you to kind of tell you what I'm expecting. So on the first one, it says, if it rains, then the ground is wet. That's the conditional statement. The converse, let me write this on the side. This is the converse. Right, this is the converse. If the ground is wet, you'll notice I've highlighted the hypothesis and the conclusion, and I'm just going to switch them. So if the ground is wet, then it rained. All right, you'll notice I have to rephrase it. I didn't put it rains, but I just said it rained. That's okay if you modify the word a little bit. All right, so if the ground is wet, then it rained. Most people might say, well, yeah, that's true, but it's not always true. And here's my counterexample. Maybe I have the sprinklers running. Maybe I'm watering the grass, and I wet the ground with the sprinklers or a hose. That is possible that I wet the ground using my own water and not the rain. Right? So in this case, this would not be true. All right, go ahead and see if you could do the rest of these. The rest of these have to do with shapes. What do you know about squares and rectangles and 90 degrees? You might want to look up some of the properties of our shapes that we have from our handout. Well, I guess it wasn't a handout for us, but I think we did this the first week or two. In chapter 1, for sure, we talked about the different shapes, 16 different shapes. That might help. And I notice I see vertical angles here as well, so you might want to review a little bit about your vertical angles. So see if you could get those done, and let me know how it goes. Alrighty, that's about it.